Okay, this is Andrew. I'm back. Again, we have our little picture here of our computer transferring. We went through a number of things, and this is our current model. Okay, so I'm going to take that current model, and I'm just going to, for the moment, just for fun, I'm just going to scale it down and kind of add a few more of these computers to the network. Okay, so you can kind of see here's our computers on the network. So here's our layers. We have this um, layer 4, layer 3, layer 2, layer 1, and then this is representing layer 7. So let's just keep that in mind. This is not like an official textbook model. This is just something that I'm putting up here for you to understand a little better, that what the computer looks like, what we've been doing at this moment. So you can take these buffers, break them down, pass them over to this computer over here. You can take them and break them down and pass them over here. So the idea is we've been looking at kind of what the computers have been doing, right? So we want to move away from that because we want to be networking people. But in order to do that, there's more stuff we have to understand. But while we're starting to understand it, I want you to still remember why and what we did on these computers. We took the data at the application layer out of the buffers and transferred it over to another computer. Well, I could transfer it to this computer or to this computer, but what's going to happen if I transfer it on this line? Is it just going to go to all the computers? Or how do I get it to only one computer? These are the kind of things we're going to try to understand over, the next rest of this course, basically. And we're going to simulate those things on GNS3, and we're really going to learn a lot about it. Okay, but first, before we try to be the network engineers right here, we want to be living in this world and working on this network, designing it, repairing it, whatever. But in order to do that, there's something we have to know, and that is really, we're going to have to know subnetting. And in order to know subnetting, you're going to have to know binary numbers. And you got to know this really well. There's good news and there's bad news. Bad news is it can be kind of complicated, especially if you've never seen it before. The good news is there really are a lot of shortcuts, and you don't have to know everything that's always presented in every course. I can guarantee you I can teach you to subnet pretty much everything in your head pretty quickly. I've had students that have told me they love networking, but they're not good at math. They've never been able to do subnetting. Once I got done with them, they could do subnetting, trust me. And I'm not the only one. Other people can teach subnetting too. There's, so other people do it, you can do it. It's really not that difficult. And this is the how subnetting is often taught. Right, here's you, and then here's who's ever given it to you, right? Well, that's not what we're going to do. This is what we're going to do. Here's you, and I'm going to show you how to do subnetting. But there are many ways to do subnetting. But first, I'm going to give you the hardcore strike you with lightning approach. This is the official long version, textbook version. Then after that, I'm going to give you a super simplified method that I use in all exams. At work, Cisco exams, I can basically subnet pretty much anything in my head, at least at layer IPv4, pretty much instantly, okay? So don't worry about this. A lot of times learning things is just being patient. Don't worry about this if you get lost or clueless for a while. Just watch the videos. Watch them all the way through one time, and then if you don't pick up, go ahead and watch them through again. I wouldn't waste time watching videos over and over, because I think the way I'm presenting it is I'm giving you the big overview and the textbook version, and you can pick up what you can, and then I'll start giving you a common sense attack where you can really start doing the stuff quickly in your head, and whatever you picked up from the textbook version is going to help you. And then, you can go look at other people's or go back over it, and it's going to be okay. Don't worry about it. I'll get you through this. Okay, so we're not even gonna be approaching subnet in really anytime soon because we have to do binary numbers first. Okay, so right now we're on the strike you with lightning approach, and we have to know binary numbers. For some people, this may be a review. It might be such a review that you just skip it. I know a lot of times I watch CCNA videos, and I usually just skip the subnet and portions at these points. So if you want to skip these, if you feel like you're a subnet and pro, by all means. But we're gonna walk through binary. And like I said, just trust me. I've done this before. I've taught people this a number of times. Just watch it. Hang in there. Don't get panicky. Just have a little patience, and soon you'll be able to subnet everything in your head. Okay. So the first thing we got to do is we got to convert a decimal to binary. Okay. So let's just take a quick look at first of how decimal numbers work. So from here, you have the number 5,021. And really, that's just one one. It's two tens. It's zero hundreds, and it's 5,000s. I mean, you can just look at it as 5,000s, two tens, which is 20, and one one. Or 5,021. I know what you're saying. That's so simple. Why did you even explain that to me, right? Okay, 5,000, 0, 20, and 1 is 5,021. Okay, well, let's just do the same thing with binary numbers, okay? What number is this? It's not 1,010 because now we're doing binary, okay? So binary is just times 2. So um, decimal actually means 10, so each placeholder is times 10. Well, here each placeholder is just times 2. We just have 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and that's it. This is actually what's called a 4-bit number because you have four bits, okay? So I have 1 0 1 0. Well, I have the good. It's really easier than decimal numbers, really, because it's either 1 or it's 0. So I have 1 8, 0 4s, 1 2, and 0 1s. So how many? How many 8s do I have? 1. How many 4s do I have? 0. How many 2s do I have? 1. How many 1s do I have? 0. So then you just add them up, just like you did with decimal. The process is the same. It's just instead of going by tens this way, instead of 10 times 10 is 100 times 10 is 1,000 times 10 is 10,000, we just go by twos. It's 1 times 2 is 2 times 2 is 4 times 2 is 8. That's it. That's why it's called binary, because binary is by 2, decimal's by 10. So really it's very simple. So just 8 plus 2. So you see here, like for example, you could have 5 tens and 4 100s. Well, here you only have 1 8. You only have 1 8, or you only have 0 8. There is no other option. It's one. It's either on or it's either off. Okay. So see how easy that is? You just converted. You just converted. You did it. Binary to decimal. It's so easy. Okay, so each placeholder is times 2, right? What's his number? You should be able to look at that instantly and get it. What? 1 8. How many 8s? How many 4s? How many 2s? And how many 1s? Bam. 11, 12. Okay? So 1 8, 1 4, 0 2, and 0 1. That's 12. Because 8 plus 4 is 12. So you have to memorize these placeholders. For a 4-bit number, it's 1, 2, 4, 8. But all you got to really do is just remember it starts at 1 and it just doubles each time. So what's this? Okay, so you got 1 4, 1 2, and 1 1. 7. That's, it's too easy. So now that you get the idea, so let's go ahead and take a look at this table. All right. So basically, here you got 1 1, which is 1. Here you got all zeros, that's 0. Here you have 1 2, that's 2. Here you have 1 2 and 1 1, that's 3. You got 1 4, that's 4. 1 4 and 1 1 is 5. 1 4 and 1 2 is 6. 1 4, 1 2 and 1 1 is 7. 8, 9, you get the idea. All right. But there's a bigger problem. Is we don't really ever look at 4 bits doesn't really mean anything. We're gonna have to look at 8 bits, okay? So let's go ahead and take a look at 8 bits. And we'll do that after this on the next video. Thanks.